Welcome. Dear student, in this lecture we have to see different data type. Data type is amount of storage allocated to the variable. The variables may be integer, it may be floats, it may be character. And if we consider the derived data type, we can use array and pointer. Now, so we have to consider data type. The data type in a C define the amount of storage allocated to the variable, the value that they can accept, and the operation that can be performed on those variables. C language is a rich in a data type. The variety of data type allow the programmer to select appropriate data type to specify the need of application as well as the need of different machines. C language support two different types of data type. First is a primary data type. Okay. In this, these are the fundamental data type in a C, namely integers. Okay. The integer may be short integer, it may be long integer. Then floating point or floats. The float is also double floats. We can use a double floats. Okay, and simply floats. Okay, and there is a different size. Okay, the data type refers the amount of storage it is allocated to the variable. Next is a character, then voids. Okay, in a derived data type are nothing but the primary data type, but a little twisted or grouped together like array, structure, union and pointer. We have to discuss all these things in a different chapter, that is array and pointer. The data type determine the type of data variables will hold. If a variable x is declared as an integer, it means x can be hold only integer value. Every variables which is used in a program must be declared as what data type it is. Okay, so while writing the program we have to declare the variables. Okay, and in variables we have to declare which is the data type. It may be integer, floats, characters, array, structure, union and pointer. Now, if we consider the integer type, integer are used to store whole number like 1, 2, 3, 4 up to any number can be stored. The size and the range of integer type on a 16-bit machine, this is the size and the range. First, integer or sign integer. The size is of a 2 byte. 2 bytes means it is a 16-bit. Okay, 1 byte is a 8-bit. 1 byte is a 8-bit. So if we consider 1 byte, then it consists of 2 nibbles, that is a higher nibble and lower nibble. Higher nibble consists of a 4-bit, lower nibble consists of a 4-bit, total 8-bit. So 1 byte means 8-bit. Here we consider 2 byte, so it is 16-bit and the range is -32768 to 32767. This is a range of this data type, that is integer, signed integer. Okay, if we consider the unsigned integer, its size is also 2 byte, that is a 16 bit, and the range is 0 to 65535. Okay, it is unsigned integer, so negative sign is not considered. Okay, short integer or sign short integer, it is of a 1 byte or 8 bit. The range, it is from -128 to 127. Then unsigned short integer, it is also of a 1 byte. The size is 0 to 255. Generally, if we have to find the range or size, okay, we have to consider the byte, okay, number of bits. Okay, in this case, if we consider unsigned short integer, then it is of a 1 byte, means 8 bit. So the range can be determined by 2 raised to 8. What 8 represent? It is 8 bit. 2 raised to 8 minus 1. It means that is 256 minus 1, that is 255. So range is 0 to 255. Okay. Now similarly we can find the range of a different integer. Okay. So now if we consider long integer or sign long integer, it is of a 4 byte. So it is of a 4 byte, it indicates that it is of a 32 bit. Okay, so we can determine the range. Okay, 2 raised to 32 minus 1. Okay, 2 raised to 32 minus 1. From this we can determine the range. The range is from -2 147 483 648 to 2147 483 647. Okay, this is a range of a sign integer, long integer or sign long integer. Now unsigned long integer, it is again of a 4 byte, means 32 bit. So range can be determined 2 raised to 32 minus 1. So it is 0 to 4294967 295. This is the range. Okay, so this is related to integer type. Now floating point type. Floating point type means it consists of a, it is in a fractional form. Okay, so we can represent it is also in an exponent form or an exponential form. So floating type are used to store the real number. The size and range of this floating type on a 16-bit machine. Okay, here integer type, but it is a floating type on a 16-bit machine is given below. First is a floats. Okay, the size is of a 4 byte, means 32 bit. Okay, it is, the range is 3.4 e raised to minus 38 to 3.4 e raised to plus 38, or 3.4 into 10 raised to minus 38 to 3.4 into 10 raised to plus 38. Now double floating point or double float, its size is of a 8 byte. So it is a 64 bit. Okay, and the range is 1.7 e raised to minus 308 to 1.7 e raised to plus 308, or we can represent 1.7 10 raised to minus 308 to 1.7 10 raised to plus 308. Now long double float. The size of a long double float is upper 10 byte. Okay, and the range is 3.4 e raised to minus 4932 to 1.1 e raised to 4932 or 3.4 e raised to 10 raised to minus 4932 to 3.4. Here 1.1 is there is again a typing mistake. There is a 3.4 10 raised to plus 4932. This is the range of a floating point data type. Now character type. Character type are used to store the character value. Okay, and for 16-bit machine, the character or sign character is of a 1 byte. Sign character is of a 1 byte, that is 8-bit, and the range is a minus 128 to 127. Okay, unsigned character is also of a 1 byte, but the range is 0 to 255. Now wide type. So wide type means no value. This is usually used to specify the type of function which return nothing. We will acquainted to this data type as we start learning more advanced topic in a C language like function, pointer, arrays in this chapter. Okay, if you can note that each compiler can be decide appropriate size depending on the operating system and the hardware for which it is being written, subject to the following rules. First, short are at least 2 byte big. Short indicate that is short integer, it indicate that. Long are at least 4 byte big. Okay, short are never bigger than integer. Integer is it is of a 2 bytes. Okay, integer never bigger than longs, that is long integer, long floats. Okay, figure show the size different integer based upon operating system use. First, if we consider a 16-bit compiler, Turbo-C or C++, the short is of a 2 byte, integer is of a 2 byte, and long is of a 4 byte. Then if we consider 32-bit compiler and a Visual C++ is used, then short is of a 2 bytes, integer is of a 4 byte, and the long integer or long floats is of a 4 byte. Now, the essence of all the data type that we have learned so far has been captured in this table. First, sign character. Data type is a sign character. The range minus 128 to plus 127. It is of a 1 byte. While we use this data type in a input or output, in the format we use %C. Okay, unsigned character, the range is a 0 to 255. It is of 1 byte and format is a %C. Short sign integer, the range is minus 32768 to 32767. It is of a 2 bytes and format is a %D. Now short unsigned integer. The range is 0 to 65535. It is of a 2 byte and we use format as a percentage u. Then signed integer, its range is minus 32768 to plus 32767. It is of a 2 byte and we use percentage d. Then unsigned integer, its range is 0 to 65535. It is of a 2 byte and we use percentage use as a format. Then long signed integer, its range is minus 21474836482 plus 2147483647, and it is of a 4 byte and we use the format is percentage LD. Why L is used? Because here is a long integer. Then long unsigned integer, the range is 0 to 4294967295 and it is of a 4 byte and we use format percentage LU. Okay, why U is used? Because it is a unsigned integer. Why L is used? Because it is a long integer. Now floats, the range is minus 3.4 e raised to 38 to plus 3.4 e raised to 38. It is of a 4 byte and we use percentage F for the format. Now for a double float, we use the range is minus 1.7 e raised to 308 to plus 1.7 e raised to 308. It is of a 8 byte and we use percentage LF. L is for long or double floats. It is for double floats. Okay. Now long double floats, it is of a 10 byte. We know that, and the range minus 1.7 e raised to 4932 to plus 1.7 e raised to 4932 and the format is a percentage LF. Note that the size and range of an integer, short and long, are compiler dependent. Size in this figure are for 16-bit compiler. Okay, we generally discuss it is for 16-bit compiler. Integer, floats, character, all these are the range size. Okay, is for 16-bit compiler. Now this is first example. So example of a data type and its a format. First, hash include conio.h. Okay, hash include stdio.h, standard input output function dot, that is a header file. It is a preprocessor. Okay, when we use printf function and printf function as output function and scanf function as a input function, then there is a standard input output. Hash include conio.h represent when we use clear screen, get CS, such type of a function, then the conio.h is required. Okay, first, then the void main curly bracket declaration part. Now here we have to declare the variable. Okay, the variable, that is a character, is a variable, integer xy is a variable, float f1 and f2, then double floats d1 d2 and unsigned p is a consider here. So this is a declaration part. Now assign, while declaring we have to assign the value. Okay, integer a, it is considered as a 4321. Okay, long integer l, it is a 5432167. Again assign a part. C, the character C is considered as a. Integer x, which we declare, is considered as 867. Float f1 is considered as 4.3214. Then double float d1 is considered as 8.5467342. Then second float f2, it is 20.000. Okay, then d2, it is also a floats 3.0. Okay, all these, that is variables. Okay, then we assign all the values, okay, are terminated by semicolon. Okay, now we have to displaying the value. For that, when we have to display the value, character, integer, floats on a screen, we required output function, that is printf. Okay, c is equal to percentage c. Why we use percentage c? Because c is a character. Okay, and when we use the character, the format is a percentage c slash n, it is for new line, comma c, and it is terminated by semicolon. Second, printf, x is equal to percentage d. Why x is equal to percentage d we use? Because x is an integer. Okay, x is an integer. For integer we use percentage d, and y is equal to percentage d, it is also integer, but y is displayed on a new line, so y is equal to percentage d slash n, that is a new line. Okay, comma x, comma y. Okay, now this format is represent in double inverted comma. Okay, and the variable is also represent after representation of a format. Okay, and separated by colon. Okay, so next is a printf, l is equal to percentage ld. Why ld, percentage ld? Because it is long integer. Okay, slash n, okay, for new line. Okay, both this is in a double inverted comma, l is a variable, that is a integer. Okay, next is a printf, d1 is equal to percentage 0.7 lf. Okay, slash n. Here l is for the double floats. Okay, double float, or we can say that long floats. It is of a 8 byte. Okay, slash n. Okay, for new line. Okay, and comma d1 is there, again variable we use, and it is terminated by semicolon. Now printf. Okay, p is equal to percentage u. Okay, slash n. It is unsigned integer, so that we use percentage u, comma p. Okay, and terminated by semicolon. So this is a declaration of a variable, and for that we use different data type. Okay, a character, integer, floats, double floats. Okay, so all these are the different data types. Generally these are the primary data type. Now second example, consider main. Okay, the character is a c, unsigned character is a d, integer is I, So this is a declaration of a variable. We are declaring all the variable, that is character, unsigned character D, integer I, unsigned integer J, short integer K, unsigned short integer L, okay, long integer M, unsigned long integer N, float X, double float Y, long double float Z. Okay, all these are the variables, okay, which include all primary data type. Okay, now for character we use scanf. Scanf is for, it is an input function. Okay, printf is a output function. Okay, percentage C, comma, and C, comma, and C. So argument is and C, and second argument is a and C. Why percentage C and percentage C required? Because C and D are the C and D are the character. For that we use percentage C, percentage C. Now display this C and D on a screen. For that we use output function printf. Printf in bracket percentage C in a double inverted comma, C, comma D, and the bracket is terminated by semicolon. Okay, again percentage C and percentage C we use in this output function because C and D are character. Okay, C is a simple character and D is a unsigned character D. Okay, now integer, we have to represent integer. Format of a data type. Scanf, it is input function, percentage D, percentage U, argument is and I and J. Okay, what did it indicate? I and J. I is a integer and J is unsigned integer. Okay, J is unsigned integer. Okay, so by using scanf function we give input. Okay, and by using printf function we display that input on a screen. So printf percentage D in a double percentage U in a double inverted comma, I, J, terminated with semicolon. Okay, now short integer. For short integer again we use scanf function. For it is an input function, so percentage D, percentage U, and K and L. Okay, why D is used? Because it is an integer. For short integer we use a percentage D, and for long integer, for short integer we use percentage D, and for integer we also use percentage D. Okay, for short integer, unsigned integer we use percentage U, and for integer we also use percentage U. Okay, so there is no difference. Okay, so scanf percentage D, percentage U in double inverted comma, first argument and K and I. Okay, printf, for it is used to display the input on a screen, that is K and I on the screen. So percentage D, percentage U in double inverted comma, K, I, terminated with semicolon. Now we have to display the long integer on the screen. Now scanf function, it is again input function. Our input is M and N. Our input is M and N. M is a long integer and N is a unsigned long integer. Okay. Now we use in a input function, that is scanf function, we use percentage ld, okay, percentage lu, okay, which are in double inverted comma, and m and n. Okay, now we have to display m and n on a screen, so we use printf function, which is percentage ld, percentage lu, ld long integer, long unsigned integer. For that we use u, lu, comma m, comma n, and terminated with semicolon. Now floats, double floats, okay, and long double floats. For that, input function is a scanf function, percentage f, percentage lf, percentage capital LF. Okay, argument are x, argument, second argument is a y, and third argument is a z. Okay, x is a float, okay, therefore we use percentage f. Y is a double float, therefore we use LF. Okay, and z is a long double float, and therefore we use capital LF. This is the input function. Now we have to display this input x, y, and z on a screen, computer screen or a monitor. Then we use printf, percentage f for floats, percentage lf for double floats, and percentage capital LF for long double floats, comma x, y, and z. So these are the different data type. It's a range, its format, its representation in the program.